Good morning, class. Good morning, good morning. Okay. My name is Ezola, and today I'm here to take you on a course on psychological and theoretical basis of mathematics instruction. And of course, MAE 608. And today's section is overgeneralization in integral calculus. So now, I'm sure most of you, many of you have learned differentiation and integration, right? Good. And sometimes you usually class say integration is what? The reverse differentiation. True or false? True. Okay. So now, today, we will now differentiate everything. So now let's explore overgeneralization in integral calculus. So now, many students often carry rules they have learned and apply them too broadly. Now, in calculus, this is overgeneralization. For example, a student applies a correct rule for a constant to more complex function where it takes longer to work. So now the goal here is what? Show with a simple scenario how this error happens. So now, what is overgeneralization? Let's find out. Overgeneralization in mathematics happens when a student applies a mathematical rule, idea, and concepts that are valid in some cases and incorrectly applied to all cases without checking the conditions. So in a simple term, usually we believe that all four-sided figures are squares. True or false? Are you sure? All four-sided figures are squares? No. So now let's mention some four-sided figures you know. Yes. Trapezium, good. Parallelogram. Rectangle. Rhombus, and so on and so forth. Now, in integral calculus, this often means applying integration rules to functions where they do not hold. Applying a rule beyond its valid scope in calculus, students assume one integration pattern works for all functions. You know, in integration, there are some rules. There are some rules that we usually interchange. And so, what are some of these rules we have in calculus? Dot rule, power rule, chain rule, and so on and so forth. That is good. Now, but today our main focus will be on the power rule. Our main focus will be on the power rule. And what does the power rule state? Even before we get into that, now let's differentiate this. 2 power x. Let's differentiate 2 power x. When we differentiate 2 power x, what do we get? Yes. It will give us 2x. That is great. Now, but we usually say integration is the reversal of integration. Integration is the reversal of differentiation. True or false? So now, when we integrate 2x, will we get x power 2? No. So now let's find out. What does the power rule state? So now the power rule states that the integral of x power n x is equal to x power n plus 1 all over n plus 1 plus c. That is what it is. equal to -1, what happens? It means we can't use this, what the power rule says. That's what it means. When n is a negative, we can't use the power rule. So that is where we usually overgeneralize. Are we together? Okay. So now, when x is -1, so now, for example, the integral of 1 out of x dx is equal to what? X power 1 all over 1 plus c. And this will give us x plus c. Now, so this is equal to what? The lane absolute value of x plus c. Now let's solve this question. Well, the integral of x raised to the power -2 to x. Now, this is equal to x power bracket -2 plus 1 all over bracket -2 plus 1 plus c. And this is equal to, we have the -1 over x plus c. Now, the implications of this overgeneralization. Now, why overgeneralization occurs in the classroom? Why does it occur in the classroom? Why it occurs in the classroom? Yeah.
Memorization without deep understanding.
Good. That means we just memorize the power rule without understanding the question. So when the question is in the negative, we just simply assume it's in the positive. Then we use the general formula, which is not supposed to be the case. Next.
Weak concentration between aspects and application.
Weak connection between concepts and application. What that means is that we don't connect the concepts with the application. We just apply what is just in our mind. What we memorize, we simply just apply what the question says. Now, the teachers have a role to play in what? In dealing with this overgeneralization. Okay, now what are the roles the teachers are supposed to play? We have to use what? Examples and counter examples. So that means we have to use what? More examples. So that you understand these concepts. So we understand that when it's negative, there's what? A different what? Formula. Now, our teaching strategies. Here we use concrete examples. So here we use the graphs so that you see that there are differences. We use problem poses that ask students to predict before solving, then provide valid context for integrals. Now, here are some of the sources we got this information